Hello and welcome to Dinis Guarda, YouTube podcast series powered and in partnership with our platforms openbusinesscouncil.org, citiesabc.com and fashionabc.org. We are here once again to talk and I would say discuss and research about the biggest topics of humanity, but as well to talk about people and people that are doing things that make a difference. I think if you look at the noise of the news, I think across the board in the last months, I think we have a problem with our media. It seems like the world is going to finish tomorrow. But there's a lot of great things happening. There's a lot of great technology being created. And I think you need to rise above the noise, above the criticism about the negativity, and look at the fantastic things that are happening. And I think that's what we're trying to do here in this podcast. I think I'm obliging myself to focus completely on the positive and the case studies that change humanity, but as well the technology. And this is a business and technology podcast. And our focus is precisely to highlight how the fourth industrial revolution, how digital transformation technologies, how the blockchain, metaverse, and AI can actually make a big difference. And that's why I bring to the table and to this series the people that are making this difference and leading these narratives. So today I welcome to our series Kåre Kjelstrøm, that is the Concordium Group CTO and CPO, and a fantastic personality that has a fantastic background as well in different areas of technology, and very important, building solid technology with some of the biggest corporations in the world. Kåre holds a MS, Master in Science in Computer Science from the University of Aarhus, one of the leading universities in Denmark, and joined Concordium from a hyper-growth American pre-IPO startup where he co-managed the Core Infrastructure Group. And before Concordium, Kåre was previously a manager at Uber Running, Core Storage Building, a highly scalable distributed ledger and storage solutions facility. Kåre started initially from Denmark and later moved to Toronto, Canada, where he doubled the site lead, bringing all of Uber's Toronto operations under the same roof. So, of course, a big brand that he actually was leading as well. He's a senior engineer leader with an extensive hands-on experience in building systems at scale. He has a proven track record on design and delivering large distributed systems, especially infrastructure technology, in different multi-heterogeneous environments across multi-cloud and in the areas of engineering, software architecture, but as well, Kåre is as well a person that has been always looking at the academic and the research side, especially with the areas of mentorship and teaching, and enjoys defining, implementing, and running large-scale IT systems. So I think just to finish early on his career, Kåre was a co-founder of the consulting company Silverbullet, where he helped drive the digital transformation of the Danish public sector with a focus on PKI secured service to service communication. And the company designed and implemented the iOS and Android application Medicine Check for the Danish Medicine Agency, which is the national medical service of Denmark. The app is free and allows citizens to read product guidelines for medicines, scan barcodes to get the product at end, and a lot of different things related. Kåre is as well a writer and a blogger, and he has contributed to the Nordic Workshop on Programming Environment Research as a co-author for a case tool for calm development, and also for the Uber Engineering blog on how Uber Engineering evaluated coding and compression algorithms. So, and now, of course, he's leading a big blockchain technology platform that I think we discussed already with the co-founder, but I would like to highlight for this series. So welcome to our series, Kåre.
Thank you so much, Dinis. Happy to be here.
So an impressive CV, and I want to start with the basis of your career. So from Denmark to Canada and the world. So a bit of how does it start, that passion for engines and machines and engineering, and as well, how did you went through your trajectory?
Well, it dates back to the 80s, actually. I'm one of the fortunate who had a Commodore 64 when I was a kid. And prior to that, my mom and dad are school teachers, and I got the opportunity to actually borrow a computer from the school over a weekend, and I was just completely sold. Instead of playing games on it, I started looking at the code already on day one, pretty much, and just trying to change stuff and see what happened. And then from then on, I just constantly nagged them on borrowing that computer until eventually I ended up getting that Commodore 64. And that was my childhood, right? Commodore 64, Commodore Amiga, then into PC. And I think I spent the better part of the time that other kids actually run around and play football, basically hacking along on these machines, coding assembly, C, and all kinds of demos and games and whatnot on those machines. So that's how it all started. And then eventually I decided, hey, maybe I should just study computer science because it seems like a logical next step. I also enjoy writing, as you said. So I was actually a little bit torn whether I should pursue a career in writing, but I think I made the right choice, first of all, because this space is so interesting and so many things are happening, and you can actually add writing on top of that. So it's not like I disregard that. So yeah, and so after that, I was working a few years as a software engineer at just basically a telemarketing company where I started out as a manager actually initially, but a coding manager. So I had a small team of 8 people working for me. And that was a learning experience at 28 to step into that role, be part of a leadership group, and I really enjoyed that. Then moving to the States, working in Silicon Valley for 3 years during the dot-com bubble and bust and 9/11. Those were hard years in many ways for the Silicon Valley. There were so many companies failing, and sure enough, I worked my way through 3 of them at that time because of the same reasons. So yeah, and then came home, as you mentioned, worked 10 years in my own company, built that up and helped digitize the Danish sector. And then I think when I look at that, right, that was prior to joining Uber. What always fascinated me about computer science is really, the blend between the real and the virtual. And that's what you get when you start digitizing stuff. And then the first wave of digitization, of course, when I was 16, I got the opportunity to write a piece of software that would help the local airstrip basically handle flights that came in and left again, and they had to do a little bit of tracking and reporting to the national air agency in Denmark. And I was fascinated by what that was. But what I did actually was I just basically took whatever forms they had and I emulated those on the computer, right? And that's just the basics, but that's not really where it gets interesting. And because that's just efficiency. Where it gets really interesting is when you see the emergence of new things that weren't possible before because you blend tech with the real world. For instance, the invention of the smartphone enabled Uber to rise, right? So back in 2009 is when Uber started, and Apple launched iPhone 1 in 2008. So prior to that time, it wouldn't really have been practical or possible even to launch Uber. There were cell phones before, but they weren't really smart, right? So the fact that you now have one gadget with all of these sensors and connectivity and a nice screen and everything on it was enough for that technology to become practical and emerge. And all of a sudden now you can find yourself anywhere in large cities. You just click a button, you get a ride, and you go somewhere, which is magical. The first time I remember experiencing that was when I was interviewing at Uber in 2014. And standing there in San Francisco and pressing that button, seeing the car pull up, just get in, go somewhere, that was pretty magical. So that enables something that wasn't there before, namely empowering people who just have a car to make a living off of it without having a taxi license. And of course, that also created a lot of noise and has been one of the controversies around the globe that Uber has been involved in. But then moving on from Uber, I went to, you call it a stealth mode startup. I think that's what's on my resume. Because it's a stealth mode startup, I worked for Cloud Kitchens, which is Travis Kalanick's newest startup. And that's the same thing. This company blends, building kitchens that you rent out just like in a WeWork setting, and then they wrap the whole thing in technology. And the kitchens are only made for takeaway. But again, the same fascination, right? It's the mixture of what you can do with the real world, and then when you start doing stuff where you bring in technology, you can improve on a lot of things. And I can't say much about it because I'm under NDA, but I'll just say that this company does the same as Uber did. They're basically pushing the limits, right? At Uber, for instance, they will feed in events in a given city and say, hey, tomorrow there's going to be a soccer match. It's going to be up here, and when people exit the stadium, we know for a fact that there will be a rise in demand on cars. So we might as well take advantage of that. And then 30 minutes before, we'll start sending text messages out to drivers who are on their couch and ask them to get off the couch, get in the car, by telling them basically that in 30 minutes, prices are likely to go higher in this area. So if you want to make an extra buck, you can go up there and help pick up these customers from the soccer match. That kind of thing is hard to compete against if you're a taxi company, right? And that's really where technology can go in and improve your business and enable new ways of competing and working. And yeah, so it's not just the magical experience being picked up, it's also the ability to push the boundaries of what's possible on the business side. I think that's my fascination. And now I'm in a blockchain company, which is also extremely fascinating, a super fascinating space, where you also see the same thing, right? I think as a person, I've never been fascinated by cryptocurrencies per se. I think it's interesting that you can have a currency that transcends nationalities and national interests. That's super interesting because that creates new things. But the whole space has been turned into this whole investment thing, and I think that's not really where it should go. Right? Where it should go is really about how blockchain can help businesses improve by making more money or saving money, and how blockchain can become an enabling technology for people to do business and interact with each other in new ways that weren't possible before. That's really what interests me, and that's also what we are aiming at in Concordium. We're more like a blue collar blockchain, if you will. We are for the masses, but we are also aiming to become a blockchain that more traditional companies will feel safe working with, if that makes sense.
That is more important than ever. So before we go to Concordium, I want to touch two things. So let's look at the first question is, how did you look, the end of the day, coding and engineering is all about architecture, systems, and how you put that together. Which writing it is about, even if you are creative writing, you still have to have a process, you still have to have some kind of things. And I know code is right now, there's a lot of new areas of coding. So how do you see this evolution of coding, writing, and engineering? Because in the end, coding is almost like the new language of humanity, but as well now there's the no-code language. There's a lot of tendencies on that. And as a researcher, you have been touching all of this. So I would like to touch that because it's more technical, but for people listening to us, it's super important as well, because we have to demystify these things in order to understand it.
Mm-hmm. Yeah, so when you build software, there are like several sides of it, right? There's if we take Concordium as example, it's a blockchain. It's a piece of software that's based off scientific research in a pretty complex area. I mean, cryptography is not for everyone. It's definitely something that requires a certain amount of understanding to understand the theory underneath here. At the same time, you want to create a product that the masses can use. You want to make it as easy as possible for other developers to come in and express themselves and build the applications that they need to be able to build, and basically lower the bar there to ideally a sort of a no-code situation where they don't even have to code, but where people with logical skills, but maybe no coding skills or very little, are able to actually express business rules or something that can turn into a piece of program that people can use. So when you design such a system, and you design a system that has to be a platform for us to build on, you have to make sure that you build something that's robust and secure and evolvable. There's like a lot of non-functional criteria that you look at, right? So you want to be sure that, first of all, that the code you produce is of a high quality. So that's really basic, right? Whenever we hire someone, we always set up a sort of coaching situation where the new hires learn about how we do here in our company. And it was the same thing at Uber, Cloud Kitchens, and other companies I work with. You have this whole idea about what is the way we express ourselves here? Because just like in when you speak Danish or English or any other language, there is different ways of expressing yourself. If you read one author and another author in the same language, there will be different ways that these authors are talking about. Some will have like a very formal language, and others will have super simple language. And it could even be the same story told in many ways, right? The same thing is true for coding. So you will have coding standards that you use. Those will be implemented in the tooling that people are using. So there will be these types of pieces of software called linting that basically checks, are you following the structure that we usually use here? And the importance of this is when you put a piece of code into a large code base that multiple engineers are contributing to, you want it to be easy for some other engineer to pull it off the shelves and edit it. That means the lower the bar is for that engineer to actually understand the code, the better, right? And if you have your own exotic style of writing something, then that other engineer will be like scratching their head and it's like, oh, I wonder what this thing is actually doing, right? And now you have to sprinkle it with lots of explanations all over the place in order to do that. So coding standards are extremely important. You mentioned architecture. Architecting something is really about setting up the structure. And this is something that typically senior engineers will be doing, right? And again, the architecture of a piece of software, the importance of that cannot be stressed enough. If you create a brittle architecture, then there are a number of non-functional aspects that you will not be getting. Like, for instance, you might miss out on being able to evolve your software. Typically, you build something and then tomorrow requirements change a little bit, and then you want it to be as easy as possible to tweak the existing software and make it and turn it into the new requirements that you had, right? So you're thinking about how you can separate concerns, for instance, within when you're building a system. Typically, the data layer is separated from the business logic layer, is separated from the user experience layer, and you might have multiple UI layers, and then you can also be thinking about how you segregate the network layout from all of this, right? And that way you create very well-defined interfaces between sections of your program. And within those interfaces, you have strict rules about how you communicate between the different layers or the different areas of your code. And if you follow those, then it becomes easier for you to evolve your software. So like multitudes of different paradigms have emerged over the years. Typically, object-oriented programming is one of them, and then component-based software development. As you mentioned, I wrote an article about that many years ago, how you could componentize things. Microservices has emerged as a relatively more recent way of structuring code. Web services is another way of thinking about it, where you think about the web as a medium of communication, and you can expose these discrete functions that then systems can call over the internet to get a service executed, and then get some information back or deliver some information. So it's all about these way of structuring information in a logical way with clear interfaces that really talks about how do I connect to this thing, because that gives you the ability to evolve the implementation on the backside, right? So think of it a little bit of a good analogy, I think, is a socket, an electrical socket. Typically, you have a piece of electrical cord that you can put into the socket. But I mean, if I take my Danish sockets and then I go to Britain and I try to put it in that, it won't actually work because they have different socket types over there. So that the interface is not compatible, right? So you want to be sure that the interface is compatible, and then you can always change the wire, you can change whatever is behind it. And that's the magical of the electrical socket system, that you can actually plug in any electrical device as long as it adheres to a few standards about how many volts it takes in amps, and that it has like these plugs, right? The same thing goes for building software, right? Where you want to be sure that you have a well-defined interface and it gives you the ability to evolve on the backside. So there's a lot of things to building software that's important, and I mean, these are just a few things. You want to think about scalability also. How do you build a scalable solution? And this is one of the things that companies like Uber are extremely interested in, because first of all, I mean, if you have a business that grew like Uber's did from 2012, I think, and up until at least 2020, the company had it was a hypergrowth company, literally, where, I think from 2014 to 15, we grew by 600% in terms of the number of trips that were taken or something like that. Then it becomes extremely important when you have like a hypergrowth company that you have a strategy for scaling out your storage One thing that's interesting, for instance, is when you have a growth like that, you might think that it's a good idea to take the data that you're not using that much and put it on some cheaper storage. Sure enough, you can do that, but if you have a 600% growth, then yes, last year's data is just a small fraction of this year's data, right? And that way, it doesn't really make much sense. You might be better off focusing on how you can compress what you already have and how you can scale out and add more storage as you go along in a horizontal kind of fashion. So you can just add more to it. And designing something like that is not trivial, actually. Designing horizontally scalable systems. And this was one of the challenges that the team I was working with at Uber took up, and we actually built a horizontally scalable NoSQL database from scratch, which is today still the biggest data store at Uber, and it has petabytes of data across multiple data centers. It's a super interesting application and an architecture as well built for scale, right? But that's just one of the layers, and at top of that, you have your whole business layer of components that make up the actual system, and there again, you want to be sure that that also scales out horizontally. And today, there are open source tooling around that you can download. Kubernetes, for instance, is a great such example, which I used in a different capacity. But at Uber, we were building our own. So we were building basically this system that where if you were running out of compute power, automatically the system would detect that and just spin up a new process that would then help take the load, right? And then that way you can simply scale horizontally and just add more and more machines in an automated fashion, which is again a critical, right? So having the ability to spin up multiple machines, having redundancy is also an important factor, making sure that you have multiple copies of your data, because if you lose a machine, for instance, a machine with interesting data on it, and you're not able to recover the data, well, then that's not a good situation, right? So you want to be sure you keep the same discrete data item in multiple locations. And now, is it enough to keep it on one machine? No. What if the hard disk drives dies? Okay, so maybe you put it on multiple drives on the same machine. Still not good enough if the power goes to that machine. You can put then multiple machines on a rack and put the discrete data item in multiple machines on the same rack, but then the power of the rack can go out, right? And then you put in multiple redundant power systems on the rack, and sure enough, that's fine until the power of the entire area goes down and the data center goes down. And then it just goes from there. So we actually put up multiple data centers, replicated the discrete data items onto multiple machines in multiple racks in different data centers. That way, if you lose a data center, you still have every single important piece of data. It's an important strategy. It's also an expensive strategy. But it's by and large the same strategy we're taking in blockchain, right? Where every single piece of information is replicated across all machines. And that gives you the power also of blockchain. So like if you think about building, systems that scale, systems that are resilient to outages and these kind of things, then redundancy, the ability to scale horizontally is super important. But then, of course, there's other aspects as well, like performance, there is security. There's like all these non-functional aspects that you want to build into your system when you design. And that's where the architects come in, right? These are people who know what are the main things I need to concern myself about, separation of concerns between the layers, the horizontal scalability in all the important layers, redundancy in all the right places, security built in, and then security in depth, maybe, where you don't just have security at the door, right? That's just like saying, hey, I have this house. I'm just gonna, protect my front door, and then I think that's good enough. But then when someone kicks in the front door, then you don't have any more defenses. Defense in depth is where you do like they did in the olden days, where you had these castles with multiple walls around, and then the first wall was breached. You still had another wall you could retreat to, and then another wall you could retreat behind. Until you were in the final chamber, right? And then all was lost. So there's also these strategies in terms of security that you need to think about. How much is good enough? Because security and performance typically also are opposed forces. So the more security, typically either performance or user experience will suffer, right? The most secure system is probably, a completely sealed metal box dropped at the bottom of the ocean or something like that. But it's not very user friendly. It's really hard to get the content out, right? So that really, so oftentimes architecture is a matter of trade-offs. I think is important to understand. So what you want to know is also when you design a system, what are the trade-offs you are architecting for, right? What are the things that you really, what are the capabilities of the system you're designing that you want to pull out and that you want to make sure emerge. That was a lot of random talking about architecture and software development, but I think by and large, right, design it well, architect it well, make sure your code quality is up to snuff, use your peers to make sure that you groom your new engineers, but also make automated systems, put those in place to test and check that the code is done. Make sure you build a good test suite, that you've automated testing, that you test all layers before you deploy it, and make sure that you have integration tests that tests not just small discrete items, but test across, right? So that, I mean, I think I can talk at length about all of these items if you're interested.
No, this is very interesting, and I think it's really important to look, and I like the way you think 360, because I think one of the biggest challenges with software is that everyone has an opinion, but very few people do the work you're doing. And what you do in here is that go through the details and understand how things work. And that's actually where the business goes. So let's look at Uber for a while, because before we go to Concordium, we have a lot of questions on blockchain. So Uber is by far a massive success. And I think from a software perspective, I think people look more from the data perspective or whatever. I am a huge fan of Uber myself, because in the end of the day, just looking before Uber and now is that the fact that I can get a car coming to me in 1 minute or 2 or 5, it's a massive branch. And not just that, the transparency that comes to the industry is massive, because if in a lot of countries is a nightmare, most of them. So there was a lot of, and I know that Uber was very aggressive from a business development, but let's look from a software perspective, which is your area. So Uber really picked a simple app and made it a super app, and now it's not just about cars; is about everything. You can Uber everything, even the keyword Uberization of society is there. So from a software and perspective of engineering, what do you think were the success that made Uber what it is now? Because of course, it's very easy to criticize, but build something that works as good as Uber, whatever you like it or not, whatever you have geopolitical or some kind of principles of being against or pro, that's a massive achievement in terms of technology. So let's look at that part, because that's a big important thing people forget most of the time. And invisible work before that.
Yes, and it's an extremely good question, actually, because I think lots of companies actually fail because they don't get this right. So any piece of software being written these days has to have some kind of reason of being. And Uber is no different, right? From the idea behind Uber's supposedly emerged when Travis Kalanick and one of his friends were in Paris on New Year's Eve, and they weren't able to get a taxi. They were like trying to get to a party or something, and they weren't able to get anything. And so the idea about how about you just had this like black cab you could just call, and then it would just take you from party to party whenever you needed to. That would be amazing, especially if you could call it by way of your cell phone, right? So that was the idea. And so the idea emerged that, hey, about clicking a button, getting right where you are, going from A to B, if we can bring that to life and make that thing happen, then it is a much better experience than trying to get a taxi and hailing them on the street, and they'll just drive past you because they already have a passenger and you don't know when they're coming if you call them, and etc. Maybe you can't even call the number because it's overloaded. So having a very, very strong idea about the business that you are in, and being very certain about where you're headed with that is critical for success in my mind. That's one thing. The other thing, of course, is now you need to build it and execute, and that's where the software portion comes in. So how do you go about that? As an engineer, you can go about this in two ways, right? You could decide that, hey, we're probably going to be building a world-class system that'll have to scale across the globe. It'll have to be installed in multiple data centers, and we should probably architect that from day one. Wrong. You should not do that, because if you do that, then you will be stuck in designing your system, and your competition might be outpacing you before you even have your product launched, right? So what you do instead is you build a minimal viable prototype initially that addresses one or two key use cases that actually makes this work, right? So like the click a button and you can see the car coming, you get in the car, and the driver starts the trip, you go from A to B, and then the driver makes money, and you lose some money from your account for the trip. That's really the base use case, and getting that right was what Uber did in the beginning. The first version was supposedly built by a number of engineers, I think, in Mexico, somewhere in South America, and by an external consulting company that Travis hired. And when the code came back, it was full of comments in Spanish. And the first engineer was he was from Canada actually, and when we started looking at the code, he was like, "Oh, I don't know Spanish, not good. What do I do?" And he started translating from Spanish to English in order to just decipher what on earth was going on in the system, right? So that he could start working on it. And I think so. That's another lesson. Don't make sure that you use a common language, just like I talked about before, right? The maintainability of the code, of course, is super important. And this first version probably wasn't that. So he rewrote it and rewrote it as a more simple and simplified application. The first version that could do just what they needed to do, right? Small cell phone app, small backend, and then get it up and running. And then you iterate from there, and you constantly bring value to your system, constantly looking for what's the next thing that will bring value to me, while you take the hit from time to time. Because if you move very fast and you build software, you will always get into a situation where you accumulate what we call technical debt, right? And technical debt is not great, but it's impossible to avoid. Technical debt is when someone asks you to build that feature and launch it by tomorrow, and you decide just to wire it together, even though we know it's not going to be pretty and it's going to be hard to maintain. Then you just do it because it'll work, right? But you know that you'll have to take the hit further down the line, and you'll have to rebuild this portion, and otherwise you'll never be able to build the next layer on top of it, and you'll never be able to scale. So Uber had a very good and healthy balance in between pushing out new features, iterating on the product from the business side, taking the hit on the technical debt from time to time, and re-architecting the most critical pieces when you needed it. And then as the success started growing, right, and the company started expanding like crazy, then that poses new sets of challenges, because building at hypergrowth is completely different from building in sort of a stable environment. For instance, if you have a stable environment where you always have the same revenue year over year, you have the same amount of traffic on your website, well, your system will never need to scale out horizontally in the number of processes, right? It may have to take peak traffic from time to time, but you know what your top peak is, and that's it. But from something like Uber, where you just constantly double your traffic, every 3 months or something like that, well, then there's always some portion of the system that starts catching fire. And you can see that it's getting red hot, and now it catches fire, right? And then what do you do? So, for instance, when I joined in 2014 in April, Uber had a single database system at the time that would take all of the write traffic. It was a Postgres database, and that database, simply every single trip that was ever taken across the globe ended up in that one database. Now, the trips were also being read by multiple systems internally at Uber in order to process payments and do other things. So you needed other processes to be able to read the data that was written, right? And Postgres has this ability to have sort of a replica set up, where you can set up these read replicas that would then get the data from the one database where all data ended up, the writable host. And Uber had 12 of those when I joined. So there were 12 readable replica databases set up around this one writable instance. But because you had to have one place where you wrote the data, it was not possible to set up multiple writable hosts, right? So the reads was scaling fine, and that you could add even more read hosts if you wanted to, but the writes weren't scaling. And this one machine, what they had done is they had bought the biggest machine they could get their hands on. So it had I think 24 CPUs and a whole lot of memory, and it was basically a massive machine. So it had been scaled vertically, right? So the one machine had been scaled, but it wasn't able to scale horizontally. And it wasn't really possible to get a bigger machine. There were also some other problems with the host that limited the ability to scale up further. So something had to be done, and there were two camps. One camp said, "Hey, we should continue to be on Postgres or maybe move to another SQL database like MySQL, and we should just set up a master-master replication setup, which is where you have two writable hosts that try to agree on what was the latest record, and sometimes that can give conflicts and other nasty things. So not necessarily the best way to do stuff. And the other camp said, no, let's forget about this. Let's build a very simplistic database that can scale out horizontally, where you can just add machines as you go, right? And then you will never run out of space, because now you have this situation where you just scale horizontally. And the CTO was a brave man. He took a bet on the latter, which literally meant rewriting the whole data layer and writing a new database. And that's what we did in Denmark, in the storage team in Denmark that I was part of. So we basically wrote a horizontally scalable NoSQL database from scratch, using MySQL as storage nodes underneath, but the sharding layer on top was something we built ourselves. And then in 6 months, we built a thing and we put it into production, which was just in time for Halloween, actually. And then Uber had or Uber has, I guess, in the US, a number of holidays that are interesting, like the Halloween, for instance, is a party data, and we could see that was getting critical to be able to actually take the number of trips that were coming over Halloween. And we were worried that Uber would fall over simply because of the load of the trips that would come out of Halloween. And that was the precursor to New Year's Eve, which is even bigger. So if we weren't able to handle Halloween, we knew for sure we wouldn't be able to handle New Year's Eve. But because of we architected things in the right way, and I won't go into the details of how we did that, but because we did that, because we had a strong way of working together with US, because we made very clear distinctions on what was the interface between the actual business logic and the underlying database, we were able to pull this off. And that actually, I think 2 weeks before Halloween, I was in the United States, and we decided to basically swap the old database system out with the new. One of the tricks we did was we wrote to both databases at the same time, and then we set up validations between the data systems to see that both databases wrote the same thing and could read the same data. And we simply flipped the switch one day, and then nothing happened other than the system continued to operate, and literally the load on the systems just dropped and flatlined, so that when we went over Halloween, it wasn't even visible on the databases. And that was the beginning of that success. But then, of course, we had moved so fast that all the tooling around the database wasn't where it's supposed to be. We had a lot of technical depth, and we started building tooling around it and started adding to that and automating and building, automated scalability features into the system. And today, this system hosts all of the most of the data at Uber, and the management system that we built on top has become a management platform for all of the storage technologies at Uber, both in data infra and in the storage team. So it's evolved to become quite large systems that actually do self-healing and auto-scaling at a massive scale. So it's a super interesting story that there's a lot of learnings from what Uber has done there. But back to your original question, it's really a matter of iterating and constantly delivering value and constantly looking at how much technical depth are you accumulating, and then taking the hit when you can, right? And try to pay it off.
That's impressive. I think it's really, for people listening to us, I know that not everyone is so technical, but this is actually explains the complexity of doing this, because of course with a mistake it could take the entire system down, and of course a mistake like this can cost millions of dollars, or sometimes billions, which for instance was the case of when the US government tried to launch the Obama Care app and it crashed. So these things happen, okay? But I think a lot of the work is done behind the scenes by people like you, and as well there's a lot of trial and error, especially for the scale of what you did with Uber, which is one of the biggest apps in the planet. So let's right now go to blockchain and Concordium. So how did you come out to blockchain, and how you see the technology of blockchain? Let's forget all the crypto. Let's look at the blockchain technology, because I know there's so much myth. Everyone has an opinion, and at the moment the opinions are not very positive, especially in November, as of November 2020. But things change very fast. So I would like to hear, how do you see the technology and blockchain, especially from an engineer perspective and from the evolution of the technology?
Okay, so I joined Concordium in March of this year, so I have only been there for like 9 months at this time. And prior to my joining Concordium, as you know, I weren't in crypto. I have experience building like these highly scalable infrastructure systems in sort of a private setting, right? Because it was Uber's own data centers and the cloud. I also have experience with building, we built a ledger storage on top of the NoSQL database I mentioned. So I also have experience with building ledger stores, but again, not a blockchain. And from my previous capacity as where I have my own company, I also built PKI systems. So I've always been interested in sort of the security, the crypto, but never actually went into blockchain until now. And well, it was really by way of my network. So my CEO Lone reached out and said that by way of the network, my name had come up, and that she was interested in exploring whether I wanted to be the new CTO for Concordium. And so I spoke to her, and I spoke to Lars Seier, the founder of Concordium, and basically discussed this for a while. And then, at the end, I just decided this is too interesting. I have to try this. It unfortunately it coincided with the crypto winter that we're now in. But in all of these situations, it's also an opportunity. So I'm not too worried about the space long term. I'm more like it is what it is, right? And if you build something that isn't good enough, or it's built on thin air, when maybe eventually it won't work. So you were asking about the technology itself and what I think about what's interesting about the technology itself. But I think so if you look at blockchain technology, it's really a ledger technology where you can write records. These records are immutable. So once written, in theory, they can never be deleted or tampered with because of the strong cryptography that's built into the blockchain, and because all of the records are tied together. And then they're timestamps, so they are also ordered in sequence. And it's a distributed system, meaning that a blockchain is really composed of a number of machines that all keep a copy of everything. So it's extremely redundant. It's more redundant than the horizontally scalable NoSQL database we built at Uber. In that database, we only had 3 discrete copies per cluster, but then we would replicate the whole cluster to other data centers. But here you actually have a copy of every single piece of data on all machines, right? So heavily redundant. And which is also the secret, because the heavy redundancy is what protects the data from being tampered with in the end. And that's also why when you have a blockchain, the more nodes that help secure it, the more safe it is in reality. And I think here we need to talk about 2 things. There's like the public blockchains, and then there's the private blockchains. And to my best, right, at least the way I think about it is that I think the public blockchains is the real invention here, right? I mean, ledger technology has been around for a long time, and sure enough, you can spin it up in your own data center if you want to, and you can say, hey, I'm keeping everything on a ledger. If you want to see, you can see my ledger. But do I really trust you with that ledger, right? That's really at the core of all of this. Do I trust that you don't roll a backup on your ledger, or that you haven't built in a backdoor somewhere so you can tamper with the record? And can we really use that as sort of the place where we write our business transactions? How would I trust you, right? And that's where the public blockchains come in and say, hey, but you don't need to trust me. You can just inspect for yourself. We'll just put it on machines that are out there. And if you want to, you can download the source code yourself. You can download a binary. You can download the source code, compile it yourself, run it on your own machine. You get a copy of all the data that was ever written since day one. And whenever we write a transaction, you and I, when I transfer something to you, or we execute an application where I lend you some money and you borrow them from me. It's all visible on the blockchain because we wrote the smart contract that's also on the chain, so no one can tamper with the code because the code is also on the chain. And here is the source code, and you can read it and you can compile it and etc. Right. So that whole thing about putting your records out there, putting the code out there for inspection, making the whole thing transparent, that's what creates the trust. And the trust of being able to communicate between people and businesses and systems in a way where you don't have to use a third party that you need to somehow engage in this conversation, right? So you can take away the middleman, and that, of course, creates some interesting new emerging business opportunities like DeFi, for instance, right? Where I can borrow money from you without having a bank as an intermediary that says, yes, Dinis has now deposited the money in this bank account. and I will now vouch for you, Kåre, getting the money, etc. So you actually go away from all of that and you use the blockchain as that intermediary. So if you think about the blockchain technology, right, it's slow, first of all, right? I mean, Concordium takes 400 TPS, which is quite fast actually, compared to Bitcoin and Ethereum, but it's still not very fast compared to the likes of Visa and these other systems that write millions of transactions per second. It's expensive. We are quite cheap. I mean, because €1 per transaction, others have like fluctuating prices. Like Ethereum, for instance, also has fluctuating prices. So if there's a lot of load, prices go up. But it's still not free. And then it's slow to write, and it's expensive. It's distributed. But what it can do for you is it can provide this transparency. So what you can do with it is you cannot write all of your data, right? You would never put all of Uber's trip data, for instance, on a blockchain. That makes no sense. Simply because there are exabytes of data, and a blockchain would need to replicate all of those exabytes of data to all of the machines out there, and that would basically just blow up the blockchain really quickly. So what can you do with it? Well, it becomes sort of an add-on on top of what we already have. You have the internet, you have the mobile phones, you have all of these emerging technologies, and now we have blockchains on top of it, right? And these blockchains give you the ability to write information between systems that cannot be tampered with, where you can come afterwards and prove that this happened. So for instance, if you buy a boat from me, you can put the money in escrow on the blockchain. In a smart contract, I can put the deed in escrow. And when the blockchain detects that both of them are there, the smart contract says, oh, these two conditions are now fulfilled. It will swap the money. So the money goes to my account and the deed goes to yours, right? And that way, you get to a point where it can create something that wasn't there before, right? This emerging thing. And maybe you don't even want to put the exact deed there. What you want to do is maybe you put the fingerprint of the deed, which is in form of a hash code, because that doesn't take up very much space, and that way it's easier and faster to write and read, and therefore more suitable for blockchain. So I think we'll find that the blockchain is very suitable for many use cases that have to do with me proving to someone I don't trust, or where parties don't necessarily trust each other directly, that something happened or that this transaction took place. So it creates trust in a trustless world in many ways, is what I think is the most important aspect of blockchain, and in particular public blockchains, not so much the private ones.
So let's look right now in what you're trying to solve with the Concordium blockchain, because you guys, like you said, are more a blue chip blockchain that it was created with a token CCD, and it really there's a fantastic team. I think if I look at, like you said, Lars is someone that created multi-billion-dollar investment bank, and actually one of the biggest platforms of trading in the planet, and that worked for 20 years or something more. And as well, Lonen, the CEO, is vice chairman of Volvo Cars, and as well involved as well in IKEA. So I don't need to say more. So the team is not a conventional blockchain ICO, let's put it that way. We're talking about high-profile personalities and so forth. So just if you could synthesize what you are targeting in terms of the blockchain solutions and how you aim to take forth.
So Concordium has one ingredient that stands out from all the other blockchains out there, other than we're backed by science and based on science. You heard all about that before. We have ID built into the core blockchain layer, and we also have self-sovereign ID built into our wallets. So with Concordium, you are now able to not only have this bubble of trust, where this trusted platform where you can interact and create trust in a trusted world. You can also now prove your identity, which creates another layer of trust on top of the other one that you have. So this enables you to selectively reveal something about yourself, that you are from Europe, what is your first name, that you are a certain age, etc. And then going into the new year, we will also enable other types of claims. So, you could put your credit history in there, and you can prove that you actually have this credit history. So if you could get your Experian credit history on the blockchain as a claim that was issued to you, you would in a self-sovereign fashion be able to prove to me that you have good credit history. for instance, right? Or you could prove your university diploma to me and tell me with certainty that you have a certain degree, and that's actually and I can trace that back to the university that you were working or you were studying at, and then that way I can get the trust. So it's like a trust pyramid that you're getting, and that's what we are working with in Concordium, and playing into that whole trust space and trying to tighten the trust around communication between businesses, people, and systems, while at the same time providing a solid blockchain proof of stake, as I mentioned before, that is eco-friendly and doesn't eat up a lot of energy, and it can be run on very small machines, and that way it becomes it's like a light footprint kind of trust system that you can use to build these business applications where you can start doing business with other people without bringing in intermediaries, because you can use the blockchain as the medium of trust.
Well, fantastic. I know that I have a lot of questions here on this. I think it's the second interview with Concordia, but I think this is a much more technical one. I know that you have to leave, so I appreciate there's a lot of intelligence here. We're going to put notes about some of the things, especially what you guys are doing in terms of ID and research. And of course, you can find more on the Concordium major digital presence. So you're going to put all of that. So Kåre, I want to thank you for your time and for the great inception and the detail that you went through. This is very important. And I think for people listening to us, please do your homework more than just go and try to get a quick buck. Do your homework, because there's much more money in the long term than short term. And thank you so much, Kåre, for your fantastic insights.
Thank you for having me, Dinis. It was a real pleasure.
My pleasure.